Have you done it before?
Yeah, I looked a bit.
Okay. Which means you won't have number system, which means you won't have that much problems.
Yeah, no, you can.
So in course 1512, is a fundamental of computer science. So the fundamental of computer science, you're going to be learning based on how the computer works, especially the hardware, how the computer thinks and how it works. So
Yeah.
this is what you must expect. So in the number system, there are a few things that you need to know. We are going to work with decimal. Decimal. So decimal is most of 10. So it's like when you write a number, you can have like 2, 5, like this 2, 5, 10. When you see this 10 there, you must remember that is representing decimal and also binary. Binary is made out of 2. So normally binary is represented by binary. It's represented by zeros and 1 only. So you might find that you are having 0, 1, 1, 0. Okay, let me just write properly. I was very much relaxed now. It can be like maybe 1, 0, 1, 1, like something like that out of 2. You must remember that this is a binary. We also have octal. Octal is made out of 8. Then it can be like, say, 65. I'm just giving an example, remember. And 8. You must remember that this is octal. And then we have hexadecimal. Hexadecimal. All right. Hexadecimal is it's decimal, like decimal. So hexadecimal is made out of 16. 16. When I say it's made out of 16, what happens? You have gonna be having 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Then after that, to add up to 16, 10 is represented by A, and then 11 is B, and then 12 is C, 13 is D, 14 is E, and then 15 is F. It's ended at F because we started at 0. So normally we'll see something written A3 like that, A3, maybe written 16. You must remember that it's hexadecimal. So when you understand those parts, you will be given something. For example, you can be given 65. When they give you 65, they put it in terms of, let's say 65/8, like this way. Let's start with octa first. Or let's say it's just a number is 65. You can be given 65. They ask you to change this 65. Let's say 65. They ask you to change this 65 to decimal. When they ask you to change this 65 to decimal, you must remember that decimal is based on what? On 10. On 10. So which means when it's based on 10, you can use a table. The table is a nice way. When you use a table, you can use 10. You can divide by 10. You say, how many times does 10 goes to 65? It's going to go 6. And what is the remainder? It's going to be 5. Then after that, how many times? And then if you divide this by 10, obviously you're going to have just what? It's going to be 1, but the remainder is going to be 65. So when you read them, you read going up like this way. You can see that, okay, this is just 65 in terms of decimal. It's the same as you wrote that 65 like that, like this. Do you see that? Sometimes when you do it, let me show you another proper way. But this is the most simple one. Ne? Then sometimes when you do it, you can say, okay, you have 65. And then in 65 here, you have, when you read, you start at 10. Ne? You're going to start with 10. Let me rewrite this properly. Ne? Is 65, we're gonna put 6. Let me use red pen now. We're gonna put 6 and 5 like this. Then we're gonna start at 10 to the power 0. Then we go to 10 to the power 1. Ne? So what should you do in order for you to get this number? You can say n is going to be, if you say 10 to the power 1 times 6, 6 multiplied by 10, you can see that you are going to get 60. Ne? Plus 10 to the power 0 is going to be 0, it's going to be 1. So it's the same as 5 multiplied by 10 to the power 1, 10 to the power 0, which is going to give you 1. And when you use your calculator, you'll see that you're going to get 60. You're going to get 65. You will see that you're going to get what? 65. So this is how. So a question can say, okay, convert this number, which is 65. Let's do it. Let's convert 65 to binary. Let's start with binary now. So if I have to convert it to binary, the simplest way method, I can just write a table. Then I write my 2 there. Then when I write 2, I'm gonna say how many times does 2 goes to 65. You can use your calculator for that. Let's check. You check that, okay, if you use your calculator, like 65, you divide by 2, you will see that it goes 32 times, ne? 32. When it says it goes to 32, if you say 60, like in other words, like 32 times 2 is going to give you 64. What is the remainder? The remainder is going to be 1. You see that?
Yeah.
Then you divide 32 by 2 again. If you don't get a remainder, you don't write anything. When you divide 32 by 2, you will see that you are going to get 16. And the remainder was 0. Then if you divide 16 by 2, you're going to get 8. The remainder was also 0. You write, again, you write 2. We divide 8 by 2, you're going to get 4. The remainder still is 0. Then you write 2. You divide 4 by 2, you're going to get 2. The remainder still is 0. Then you write 2. You divide 2 by 2 is 1. The remainder still is 0. You write 2. If we divide 1 by 2, the remainder is going to be just 1. Ne? We just put that is going to be 0. You can write 0 there, but it's 1. So when you read your binary numbers, these numbers, you read them starting down, you're going up like this way. So which means if I have to write 65 in terms of binary, is represented by 1, 0, 0, 0, 0. Let's see how many zeros. 1 is this one first. Ne? We start with starting here. You start here. It's 1, 0. Is how many is it? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and 1. And then you show that is number 2. So if you want to verify that this number that we are working with here is the right one, you can use 1 is 0. How many zeros is 5? 0, 0, 0, 0, 1. 1, 2, 3, 4, 5. You can use 2. When you start, it's going to be, because we are working with binary of 2, you're going to start at 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, and 2 to the power 6. So you can see that in terms of n, if we have to, this one, when you say 0 times, you can start here at 6. It's like 1 times 2 to the power 6. Ne? I'll just write 2 to the power 6 plus this is 0 times this is going to give us everything there is going to be 0 until 1 times 1, which you can write 1. And 2 to the power 6, if you check your calculator, it will give you 64.
64.
Is 64 plus what? Plus 1, which is equals to exactly 65. So it proves that this binary number that I've
65,
just
yeah.
written now is exactly
Interesting,
equals to 65 of what? Of this number. So you can do, as long as you understand this process that I'm showing you, the conversion, you can do with any number with this method. Ne? It will never have a problem. Even if we have 68, we have 65 again. Let's use 65 again. We are going to convert this to octal. Ne? Octal, you convert it. When you convert to octal, we use what? We use we use 8. So which means you are going to use your calculator. How many times does 8 goes to 65? Like, you can use your calculator. Sometimes you don't really need a calculator. It's 8, because 8 times 8 is 64. The remainder is going to be 1. You see that?
Yeah.
Then you divide 8 divided by 8 is going to be 1. The remainder, it was
is going to be
0
1.
there. The remainder was 0. If you say 8 divided by 8. And then after that, if we divide this by 8, obviously the answer is going to be
And if you
1.
1 divided by 8, yeah.
Is. Then you go up this way. Then when you write this 65 in terms of octal, is 101 of what? Of 8. So if you want to verify it, you can write 101. You start with 8 to the power 0. You go to 8 to the power 1 and 8 to the power 2. So 8 to the power 2, we know that is going to give us what? In terms of n.
64.
In terms of n, is 8 to the power 2 is going to give us 64. Plus this one is just 0. So 1 times 1 is going to be plus 1, which obviously you can see that is 65. So you can have, they can give you any number. This one I'm just giving you, I'm just using 65 as what? As an example.
Yeah.
I'm just using 65 as an example.
Yeah.
You can be given any number as long as you understand this strategy that I'm showing you. Now, you won't have any problem to answer any question. Even if it's 65, let's use 65 again with 16. 16 is what is for hexadecimal. Ne? You just check in your calculator, you just say, how much does what? Like you just check, let me erase here. You can just say 65, you divide it by 16, you check the remainder. 65 divided by 16 is 4. We have 4 there. So when we have 4, sometimes it's more confusing. You might ask yourself, what exactly is the remainder? Ne? So you can just say 4 multiplied by 16. 4 multiplied by 16 is what?
64.
4 multiplied by 16 is 64, which means the remainder we have there is 1. And then now when you divide this one, 4 divided by 16, we're just going to write 4 here. We're going to write 0. Then you write it going that way. So which means based on the 16, your answer is going to be 4, 1. Ne? Sometimes when you calculate others, you will find that 4, 1, 16, you will find that you are getting the remainder of 10 or even 12. So now you can see that, okay, if you have this, if you want to check it, you can recheck it like that way that we did now. You can just write your 4 there. You write your 1, 16 to the power 0 and 16 to the power 1. Then after that, you calculate for your n. Your n is to get the number of decimal. Then obviously, we already showed that 60 is 64 there. And then plus, this is going to be 1, which is 65. So let's assume maybe
16 to the power 1.
16 to the power 0 is 1, remember. Anything to the power 0 is 1. 1 times 1 is going to give us 1.
Yeah, and then 16 to the power 1, is that not 16?
Is 16. 16 times 4. Remember, we are saying 4 times 16.
Okay.
This 4. We are going to say, in order to get this 64, we say 4 multiplied by 16. Eh? Then you will get 16. And in order to get this one, we use this number that we said 1 multiplied by 1. Sometimes you might find that it was 2 there. So do you understand it?
Yeah, I understand.
All right. So sometimes you can have a number which is higher. Let's say, for example, you have 420. I'm just using this number randomly there. Let's use for hexa. Let's work it on based on hexa. For 20 and we have 16. So if we are going to divide here, if you say 420 divide by 16, you can see that we get 26. Né?
Yeah.
The remainder is 26. I'll write 26. Not the remainder is 26. But now we can check something. Sometimes you can just say, minus 26 there. You get 0.25, you multiply it by 16. You see that is 4.
Okay.
So if you say, to show you that is 4, if you say 16 multiplied by, let me erase the 16, multiplied by 4, multiplied by 26, 16 multiplied by 26, you see it's 416. If we add 4, obviously it's going to get what? 420, you see. Then again, you do the same. How many times does 16 goes to 20? 6 is gonna go 1, né? And what is the remainder for this? We know that is going to be 10, is it? Because it's going to be 10 plus 16 is 26. Then again, you divide this by 16, 1 by 16. Obviously, it's going to be 0, but we write 1 there. So when we read it, you read it going that way. Then in terms of hexa, it's 1. But you know that 10 is represented by what? A, né? It's 1A4 of 16. You have converted this number to this decimal number to what? To hexadecimal. So if you want to verify, you can use the same process that we did. So we are still going to talk much about this, and then how to convert them to, maybe you can also ask yourself, okay, how do you convert, let's say you are given, we're gonna use for 65, let's use the same one we got there. We used, okay, in Octal we got 101, né?
Yeah.
Octal for 65 we got 101 of 65. Let's assume that you want to convert this number to, what? You want to convert this number to hexa, like to hexadecimal. What are you going to do? So if we want to convert this number to hexadecimal,
okay, I'm going to say start from here and then 8. And 8 to the power of 0, 8 to the power of 1.
0.
I'm going to start with 8.
No, this is octa. Yeah. Remember, this is octa. And from octa, we want to go to hexadecimal.
Oh, I want to go to hexa.
Yes. So what happens when you convert them? Normally,
then
you use a structure of 8 is 8, 4, 2, 1. So when you use a structure for 8, 4, 2, 1, you will see that if you say 16, you divide it by 8. 16 divided by 8 is going to be 2. So which means you're going to start at 2, 1. You're going to start here. So if we have to do it, sometimes the other method that you can use, you can just do what? You can just first convert it to decimal, then you go to hexadecimal. It still works proper. So when you have that, you can write this number. Let's write those number down. Okay, let me just make a space first. It's 1, 0, 1. Ne? 1, 0, 1.
Yeah.
You will see that even if I write 8, 4, 2, 1, and then 8, 4, 2, 1, 8, 4, 2, 1. Ne? You will see that in this one here, number 1, 1 is only composed of, to get 1 is when you have 8. Let me, yeah. To get 1 is when you have only what? This one here is like the first number here is going to be, this number when you read it reads like 101, ne? In terms of octal. So, but to get this one here, you can see that this one, in order for you to get it, is made by what? 1 times what? 1 times 1, ne?
Yeah.
And 1 times 1 is the same as 2 to the power 0. Or you can say
it's cutting now.
It's cutting. Oh, okay. You can see that this one here is going to be made by 1 times what? We can say 1 times 16, ne? Because we can even start at 16.
1 times
16
1.
is you can start at let's say 16, 8, 4, 2, 1, ne? We can say, okay, this one here is made by 16, but in order, the ones that we need to really write, okay, let me do this way. Let me not just talk. In order for us to get this one, ne, you can see that both here, there must be 0, 0. Okay, this one is when I'm converting to this is the method when you are converting to a binary number, ne?
Okay.
Because when we're converting this number to binary, we can say, okay, 101 is going to be made of 0, 0, 1. And this 0 here, obviously, is going to be 0, 0, 0, ne? 0. But normally, here, if you are converted to binary, you ignore 8. We don't write 8. Also 8, you cancel it. Then it's going to be 0, 0, 0, 0. And to convert this one here, which is this one is going to be what? To be able to get this one, you can see that it's also going to work with 0, 1. It's going to be 0, 0, 0, 1. So when we write this binary number, it's going to be, we ignore these zeros. They are not important for now. So you can write it as 0, 1. How many 0 do you have? 1, 2, 3, 4, 5. Okay, 1, 2, 3. No, we said we don't count this one. It's going to be 1, 2, 3. Ne? 4, 5. We have 0, 0, 0, 0, 0, 1. So this is the method. This method that I'm showing you is when you are converting to what? When you are converting to binary. So if you check, it's exactly what we got before. If we go down there, if we check, I think we did, yeah, we did with binary first. You'll see that we got exactly this number.
Yes.
So which means if you're asked to convert from octal to binary, remember you start at 4. This one, let me delete them. This 8 here is
from octal to binary. I start from 4.
Yes.
So binary is
the reason part why we are starting from 4, ne? It's because of that reason that I showed you there, that we said octa is 8 and binary is 2. 8 divided by 2 is going to be equals to what? 4.
Yeah.
So which means it's going to be 4, 2, 1.
Okay. No, I see now.
You understand it, ne?
But the first one, the first number you gave, the first, when you were converting, I see you skipped the first 3 zeros. Is that because the first one
3 zeros,
is 1 or?
It's because of when we multiply these two number 8 times, it's gonna be 0, it's gonna be 0, it's gonna be 0. You see, so when you write a binary number, if you have 0, 0, 1, 1 like that, you know, these first 2 zeros, they are not really important. You can skip them, but there will be a time whereby we're gonna be talking about these zeros when we are talking about the sign magnitude, né? Because the sign magnitude, this 0 means positive and the 1 means negative when we are dealing with bytes now. Bytes. When we are talking about the bytes, you know that is composed of what? Of 8 bits. So we're still gonna do this chapter, how to work it out. This one is when you are working on the data storage.
So can I ask, this, what we're doing right now, it's course 1521.
Yeah.
Hey, the ones I'm seeing here, it's saying Boolean expression, logic simplification. Did I maybe study the wrong things or something?
This is the beginning of this chapter. It's chapter 2.
Boolean expressions is chapter 1.
No, like the first chapter is just about chapter 1 is about speaking about computer, how does the computer works, and then like that, who was the first person to be a programmer, like, and then you see, it's just teaching you about that one is just a theory that you need to read by yourself.
Okay.
The most important chapter 1, you read it by yourself. It's just a theory that you need to understand. Then chapter 2 is exactly what we are talking about, the conversions. And then chapter 3 is about the data storage.
Okay, let me just check here.
So you can check. We're still gonna continue properly, because I can hear also the network is not fine. And because I haven't finished the timetable properly.
Yeah.
So I want to finish it. But you can go through this chapter 2. At least now you have an idea on how to convert anything there. You can be doing the exercises, because these things is very important to know how to convert them before we proceed. The way I was doing.
Okay. No, I will do this then.
All right, no problem. Then which means I will let you know when I'm done with the timetable. Then I'm gonna send it to you.
Okay. There's no problem, brother.
Hello?
I'm saying there's no problem.